Ladies and mostly gentlemen, thank you for tuning in today. It is always a good day when we get to play with scale parts. Have you ever built a custom rig? Well, today that is exactly what I'm going to do. Today's video is on the Capra, but not really, just the axles on the Capra. And I would ask you, when do you call a rig the rig? When is a TRX4, or in this case, when is a Capra a Capra? In the past, way back when we had to build crawlers uphill both ways, we took the axles from a TLT kit and we threw everything else out. Matter of fact, we threw out most of the internals from the axles as well. We chopped the ears off. We used basically the plastic housings and only the center gear, but everything else we considered a TLT crawler. And we have come so far in the market. There are so many choices that you can get: RTR, comp rigs, trail rigs, everything today. But what I'm going to do today is take a couple steps back and build up a custom rig, much like I used to do back in the day. Now, most of you that have built custom rigs before probably do it just for fun. However, a small segment of us are into competition. And to tell you the truth, it's been a really long time since I have competed because, let's be honest, I don't have a whole lot of time to travel around the US or the world anymore for it. With the family and the businesses and everything, it kind of adds up sometimes when you get a little older. But that is not going to stop me this next year. I'm going to at least go to a few events and do some competing. And what do we need to compete? Well, let's say the truth, we don't need it, but I like to have a custom built rig. So we are going to get into that today, and we are basing it on the Capra axles. So I'm going to call it a Capra, but there is actually nothing else, zero, except for the axles. And by the time we're done with this, I'm not sure how much of these axles are going to be left either. But to get to our plan today, I am going to start with these Capra axles. I still need to build one up. We have one here. Then we have these custom rails. These are cut from G10 by Chris from Team Garage Hack. He has a CNC router and cuts out the rails. This is actually version 2 they were on. That's the nice thing about being able to make your own parts, is that revisions come fast. Then we have a Creeper, or the Too Low transmission from Team Garage Hack. It has a built-in overdrive to it, about 30%. So we'll start with the stock ratios on these axles, overdrive in the transmission itself. Then we will have a forward-mounted servo on here, frame-mounted servo, not on the axles in this case. I want to go with a CMS, a chassis-mounted servo. This is also a Team Garage Hack part. He designed it specifically for this chassis. That's kind of the one thing that happens when you have a custom build, is everything has to be made for each other, or you end up doing a lot of hobbying or cobbling together parts. And since Chris and I have kind of been going together on this particular project, there's a lot of parts that are just completely custom, completely new, and built for each other. So this is actually going to be a little bit easier build than most custom builds may turn out, because we're just doing it all at once. It's a lot of engineering work to get it done. Big thanks to Chris for the time that he has spent on it. I've helped him out somewhat on this project, and you'll notice that we have some Holmes Hobbies branded products that are going to be coming out soon. But today, what we got to do is make sure that it all fits together. So essentially, let's just get to it. We already have our transmission bolted to the skid plate, and we have these sliders that I printed out. These I printed out of PETG on my Monoprice Select. And if you look at the previous videos, I printed out quite a few of these, but I'm going to use the PETG ones that look terrible on the surface because they are the best plastic. So yeah, PETG or nylon or ABS is pretty much what I would recommend for something like a slider. You can get away with PLA, but the first time you get a hard knock, or the first time you get in a hot car or on a hot rock, it's going to deform unless you anneal it. Maybe that's another one for another video, is annealing PLA. All right, so what we got to determine first is which way is forwards on our vehicle. And this one has what is called sporty lean to the skid plate. And so I know the front is lower than the rear. So there we go. Here is the front of our vehicle, I believe. Yeah. All right, so we are going to bolt it up. It really doesn't matter which way the transmission points. I'll go ahead and do this now though, because I would like my motor to rotate in the normal counterclockwise shaft rotation. So this would be our rotation. Here is our front output. It is spinning this way. Now, some of you, let me know in the comments, you may have a preference whether you put your motor on the driver's side or the passenger side of your rig. There are pluses and minuses to doing both ways. A lot of times people will do it for a weight bias and torque twist. We'll go back. We'll go back this way. Aha! There we go. Now I got it right. So it'll be on the passenger side for now. We can always flip it later. Not a big deal. We will bolt the skid plate up to our frame. Easy peasy. And because of the way it's designed, I'm going to have to flip it. Oh well. But that, as you can see, we've got these two holes on the rear. One of them is for our center link, what would you call it, the screw that holds it all together. And there is a hole on the chassis rail so that you can get to that without taking your skid plate off. So, good job, Chris, on the engineering. He's put a lot of thought into this. A whole lot of thought. All right. And sometimes it's a little fiddly getting everything together to bolt together. Wrong hole, fool. Make sure you're putting things in the right holes. Get a little longer screws. At this juncture, you can get a lot of your hardware from Team K&K. That is where a lot of people get theirs from. They have a very wide selection. It should be long enough that time. Where do you get your hardware from? I'm currently using a set of Losi drivers from, I think I got them in 2002. All right, there we go. We have a start. All right, the next part, we have this the servo mount. It has a position for both a servo and a servo winch. And anytime you put screws into metal, it is recommended that you use Loctite. I still don't have my links made yet, and that generally requires a lot of finagling, a lot of fiddling. Now, as you can see, this actually doesn't meet up. And if I do recall correctly, it's supposed to just kind of bend and come together, which G10, carbon fiber, fiberglass, all that, it's okay with that. So that's exactly what we're gonna do. Yeah, just like so. Now we have our 3-link mount for the frame. This one is 3D printed from Shapeways, but we have some aluminum ones on the way. And it threads right into this aluminum servo mount, which is pretty dang slick. You know, multiple parts doing multiple things. Let me know in the comments. What kind of screws do you use? Do you typically go for stainless? Do you go for the black oxide, which are typically a little bit stronger? Or do you go for lightweight aluminum screws? Because on a build, typically you can save almost an ounce by going to all aluminum screws. However, the first time you take a big tumble, if you have them on your shock mounts, it'll probably shear off. The stainless will bend, the black oxide usually will be fine. That looks good. All right, and I don't know if this is the actual mount we'll end up using. Like I said, we got some aluminum ones on the way, but as you can see, it's starting to look like a slider. Now we have these, front and rear bumper-ish mounts. I believe these are from an SCX-10 or something like that. This is the V3 SHV 500 servo. It's brushless, it's very fast, extremely fast. It runs on 224 cell LiPo direct. Oh yeah, it fits. And I know it's not gonna be obvious to a lot of folks unless you've built rigs before, of course, but usually your servo horn is gonna be just below your pan hard mount. Pretty excited to have a version 3 SHV finally coming back. It took us a long time to really work some kinks out. I was pleased with the V1 and the V2, but as things go along, we usually make improvements on them. I like my products to be about as bomb-proof as they possibly can, so we made some pretty big improvements to the inside. The gears are going to be a lot stronger. The pins are a lot stronger. We upsized everything just a wee little bit and kept that super fast transit time. There we go. And if you're not aware, Holmes Hobbies was the first company to come out with a 3 and 4S LiPo-compatible servo for crawlers, for the ground market in general. And of course, it's been knocked off. You know, that's how things happen, but whatever. we'll just keep on going. All right, so we got our servo in, we have our transmission in, and our sliders. The next thing for us to work on, I should probably have installed the motor before I got into it, but I haven't placed my electronics yet, and I kind of do all that at the same time. I'm going to be running a brush motor in this one, and let's just talk about the motors on this custom build. So these are some selections that I would use in a comp crawler, depending on how hard your competition is. So this is our revolver snub nose, used to be called the stubby. As you can see, it's very small, it's very light. It's about 3 ounces or so, much lighter than anything else. And when you are looking for the shortest motor and the lightest weight motor possible, this is the general choice. I really don't like competing with brushless though. But there's a lot of guys that do. There's a lot of guys that are successful with outrunners. Being sensorless, it does have essentially, there's a line where it won't produce more torque. And that is one reason why I don't use sensorless in my own rigs, even though it's pretty dang good. When you get to the upper level of competition, there's a point to where the courses are built so hard that sensorless simply is not as reliable as either a censored motor or a brushed motor. And while we could use a censored 4-pole, this would be my second choice. I'll just rate these in the choices that I would go through. This would be my next choice, away from my first choice, I should say. And this is a puller stubby. So it's shorter than a 540 motor. It is a 4-pole, really torque dense, really power dense, but it's still, about 6 ounces or so. They're listed on my website as far as the weights. It's kind of a hefty motor. It's a little overkill, and to tell you the truth, 4-poles are great for overall power density, torque density, etc., but it is still not my choice for a competition rig. They're a little bulky, they're a little overkill, and I just like a little bit better control on the drag and the descent. So if I'm not going to use brushless, I am going to use brushed. And for upper level competition, again, brushed is always my choice. So Crawlmaster Pro 540 13 turn is what I would probably run. It's a really good general recommendation on things. However, again, it's about the same size. The stubby's a little bit shorter here, but it's still a little overkill in my opinion. So the next choice, which I still will not do, Puller 400. I developed these specifically for competition crawlers. It is a little bit shorter than a standard 540. Let's see if you can see that there. A little bit shorter than a standard 540. It is lighter by 2 ounces than a standard 540. They start up smooth, they have extremely good torque density, power density, etc. This is what almost everybody uses when they're really serious about competition. Out of all the motors that we have, these are the ones that people choose. However, at Scale Nationals last year, it was Torque Masters and Crawl Masters that swept the podium. Everything was Torque Master and Crawl Master. Not a single brushless motor on the podium. Everything was Holmes, which was pretty cool. Felt really good. But a lot of the guys do choose the Puller 400 for shaving some weight. It's not as much weight as this guy, but it has a lot better control under all conditions. Except for being in mud, I suppose. But if you're competing, you're probably not getting into mud. And if you are competing in mud, it's going to be a TTC sort of event, and you're going to choose either the 4-pole because it's sealed, it goes through that kind of stuff, or you're just going to throw in a sealed can because you're going to end up ruining it in the mud. So moving on, my choice. My choice is actually going to be a prototype motor that I've been working on for quite some time. You may already be familiar with the Magnum motors, and we've discussed them before. They have a larger rotor than a normal 540 does, 28 millimeter rotor versus 23 millimeter rotor. And what I have done is I have shortened the stack, and I don't have any armatures here to show you other than the one that's built into the motor. But again, comparing to the 540 motor, come on now. It's got really strong magnets. It's a little bit shorter. It is lighter by, I think about an ounce and a half on there. It's heavier than the Puller 400. It's lighter than a normal 540. But this guy has really good torque density and power density. And it starts super duper smooth. Out of all of our 5-slot motors, the Crawl Master is probably going to be the closest, or a Custom Pro built with a skewed 5-arm slot. This also has a skewed 5-slot arm, and just super smooth starting, but still has extremely high drag, brake, and torque density. This is, as far as a competition motor, probably my best design yet, right behind the Puller 400. The 400 is such a good, just solid all-around design. It's been on the shelf for so many years at this point. But I can custom build motors, so that is exactly what I did. And I'm sorry that you can't get one of these yet. Super smooth starting. I've nailed the magnetics on this one. Kind of just a couple more pats on the back. This is what I'm going to be installing into this one, and I'm either going to go with a 13 turn or an 11 turn with the volt up, gear down. I'm either going to run 3S or 4S, probably 3S LiPo battery, and just take advantage of a really fast spinning motor with smooth startup, and then use gear down to get our wheel speed back in check. That's pretty much what I always do. That's what I always recommend, especially if you're going to be competing. You can get better power density, torque density, drag, brake, everything if you use a slightly faster motor than you probably would use, and then gear it back down. So I will be following that same formula for this guy. And here we go. We'll just pretend that it's going to be mocked up. It'll be sitting right in here, and it's a tight fit. That'll definitely work. I designed this one with 6 different holes for mounting position so that you can clock it however you need to and have plenty of adjustability. So, all right. I believe that we may be at a good stopping point for now. What I need to do is button up my electronics, build the axle, and then we can determine our link links. I do believe that a stock Capra set of links may work on this guy. I know that that's what Chris was shooting for when he was designing it, and I don't know if it actually will work. Sometimes, a millimeter off one way or another. We got to fall within a certain wheelbase, and I'm going to have to hit a certain track width as well. So next time we will be building a little bit more on this guy, and yeah, I mean, what more can you ask for? Having some fun with some cool custom parts. So let me know if you are building on a custom crawler, whether it's for competition use or just for going out and having some fun with your friends, because I think that's one of the more fun things in this hobby, is to kind of, do your own thing, march to the beat of your own drum, and that's exactly what I am going to be doing with this build. So if you do have any more questions, be sure to leave them down below, and otherwise, thanks for tuning in and have a good day.